We are going to eliminate the parameter and do this part where we're going to sketch the plane curve represented by these parametric equations by eliminating the parameter. That's the purpose. We're going to eliminate the t so that we can graph this or sketch this. And we're going to also use this restriction. So what I'm going to do is get t by itself so that I can put it into this equation. And I'll use this one to do that. So I'm going to square both sides. I have it. I can now put this over here because this t and that t are the same. So I can then say y is equal to x squared minus 1. So I have now eliminated the parameter. Now we need to sketch the curve. So I'm going to do a basic, simple, hand-drawn graph. And we know that x squared would go like this. This is the normal x squared parabola curve. Well, we're being pushed down one or going down or moving in the direction of negatives by 1. So let's say this is 1, which means the actual curve that we have is, give or take, approximately like this. And I'm not going this way yet. If I were to go that way, okay, I'll start doing that. The problem I have is this restriction. This is telling me that t has to be greater than 0. And the x values, since we're using that here to eliminate the t, the x values will be the t values, and we cannot go to the negatives of these. Right? Which makes sense from the beginning, because if x were negative, we could do it with a fifth root or a third root, but we can't do it with the square root. Okay. Now, unless we had plus or minus here to start off with that, but we're not going to have a negative number inside here, so we're not going to be able to get a negative with this x. And whenever we square this, okay, well, here we are. Let's come back to this, because we can identify that this part is valid. And another part we have to do here is show that since time goes in one direction, we have to actually go in that direction. Okay, so we're starting from 0 and moving on. So the things that you have to do here is to eliminate t, substitute here, sketch it, and include the directional angles. All right, now let's do it again. And this time let's do it somewhere one of the examples in our textbook with some trigonometric equations. So these are trigonometric parametric equations. Okay. I am not sure that's what they would call them, but it's the way I'm thinking about them that makes sense to me. X is equal to 3 sine t. Y is equal to 3 cosine t. And we're going to have the restriction that 0 is less than t, which is less than pi. Oh, an interesting concept now. It's not a number like 10 or 20 or such, although you could say 3.14. But wait a minute, with pi, immediately that gives thought to radians, and that gives thought to a curve on a graph, such as the unit circle. So let's see what happens. And it could be used for other ones as well, as you go from pi to, or from 0 to pi and over to 2 pi. Well, let's do the same exact thing that we did here. We're just going to have a few different little twists. We're going to eliminate t. Well, sine t, you'd have to do sine minus 1 of something to get the angle t, or the amount t. But we're not going to have to do that. What we're going to do first is to solve here for sine and solve here for cosine. So if I divide by 3 here, and I divide by 3 here, I'm going to get that the sine of t is equal to x over 3. The cosine of t is equal to y over 3. Now, I would look at this and say, All right, what kind of angle theorems or trigonometric identities can I work with? And we are going to go to just one of the basic ones because I can see, well, sine t and cosine t, I can't like add them and get something. It's too bad they weren't squared like sine squared t and cosine squared t, because if I add those up, they equal 1. Well, if that was squared, well, I can make that squared. This is an equal sign. It's an equation. I can do anything I want to an equation on one side or the other, as long as I do it to both sides. I have to do it to both sides essentially exactly at the same time. So I'm going to square both sides. That's going to give me sine squared t equals x squared over 9. I'm going to square both sides here. Cosine squared t equals y squared over 9. This is one of the techniques when you're solving equations or doing things, and you might not even realize you're solving equations, but basically for the rest of your life in mathematics, there are times when you might be able to square both sides of something and get something you can work with. And we have something we can work with because these two are equal to 1. So let's write the Pythagorean theorem, Pythagorean identity, that the sine squared t plus cosine squared t, it's equal to 1. Or actually, it's actually equal to itself, isn't it? Isn't sine t squared, or sine squared t plus cosine squared t? I mean, that's a basic property in math that, if it's equal to itself, it's equal. I mean, they're true. 7 is equal to 7. We know that. So sine t squared plus cosine t squared equals sine t squared plus cosine squared t. Well, sine squared t plus cosine squared t is 1. Sine squared t is x squared over 9. Cosine squared t is y squared over 9. I have an ellipse. In fact, even better, I have a subset of ellipses called a circle. Let's multiply both sides by 9, and I'm going to write it over here, that x squared plus y squared, I multiply by 9 and 9 here, again 9. I now have a center, hk, of 0, 0, and I have a radius of 3. Radius equals 3. So I have a circle. So let's graph the circle or sketch it. I mean, the purpose of what we're doing here is to sketch the plane curve, which is represented by this, and we now know that the curve that we want to use is a circle, or we want. So I'm going to make a little basic graph here, and let's say that's 3, and that's 3, and that's 3, and that's C. I'm making the graph so I get to say what it is here, or the distances that I'm going to use, as long as it's reasonable. Okay, so 3 and 3 and negative 3 and negative 3. And so if this is the center, the circle is going to come this way here. Actually, it's going to start here because, of course we start 0 because, circle like the unit circle, it might not be the unit circle here, but it's still going to have from 0 over to pi, or 180 degrees. So what we're going to look at here is, we're going to look at where we can curve this, graph this, but we're limited. We're limited to that. So we can actually only use this because we're not using 200 degrees or 270 or so on. So it's only in just this. So we're going from here to here, but we start at 0 and we'll go to pi. So we put the directional angles, and there we are. There's our answer. So we have eliminated t, because right here at this point, once I saw that sine squared t plus cosine squared t is equal to itself, well, that's equal to 1. The t's are gone. Over here, that's equal to sine, that's equal to x squared over 9, that's equal to y squared over 9. The t's are gone. We have eliminated the parameters here, and their resulting equation allows us to graph it with this restriction and include the directional angles. So the same basic steps here to eliminate: substitute, as we did here in a different way, sketch it, and use the directional angles. Okay, thank you for listening.